Okay, thanks for your patience, everybody. I just want to make sure that Jonathan, our presenter who's joining us remotely, can talk. So Jonathan, can you say something just to make sure your audio is good before we get started?
Yes, I'm here. Can you hear me now?
Great. Yep, it sounds good. Okay, I'm going to open up a poll question. We'd like to know your current level of knowledge or experience with the orbit determination process. So if you could please answer that while I introduce Jonathan, that would be great. Jonathan Lowe is an AGI systems engineer based out of our Maryland office, and he is going to be presenting for, I think, about 20, 25 minutes today, if I'm right, Jonathan. He's got 6 poll questions. It might go a little longer, so stick with us. Jonathan's going to be giving you an overview, and then he's going to walk through the software live. If you have questions at any time during the presentation, you can send them in the questions panel. We'll compile them, and then Jonathan will get to as many as he can at the end of the presentation. And like I said, we're going to be popping up poll questions, so if you could please participate in those, we'd love your feedback. So Jonathan, as soon as you're ready to start, I will shut down the poll question and give you your screen back.
I think I'm ready whenever you are, Andre.
Okay. Thanks, everyone, for your participation.
All right, so welcome, everybody. This is our first DIY webinar on ODTK, and since it is the very first one, I'm going to begin with some very brief presentation material about ODTK and what it is and how it's used before getting into the software itself. But don't worry, it's not going to be death by PowerPoint. We'll keep things brief and interactive with a few poll questions. So what exactly is ODTK? Orbit Determination Toolkit is AGI's desktop software, which provides orbit determination and analysis support for the entire life cycle of satellites and their tracking systems. It's built on top of the same verified astrodynamic functions as our STK product line. It also allows you to process a wide variety of traditional and non-traditional tracking measurements. It does this by leveraging a state-of-the-art optimal sequential filter and also a matched smoother. This allows you to generate orbits and orbit estimates and their uncertainties. And one of the key elements is a realistic covariance. It also allows you to use a measurement simulator to simulate tracking system design and analysis when real tracking measurements are not yet available. It has a fully documented API, allowing for easy automation and integration into your flight dynamics solution, including large-scale enterprise systems too. And as with STK, it's of course actively developed, maintained, supported, has a user-friendly graphical interface, extensive documentation, a comprehensive API, and has been independently validated and verified. So ODTK provides a number of important benefits. First of all, the orbit uncertainties computed by ODTK are actually considered realistic, trustworthy, and physically meaningful. It's not just a mathematical byproduct. And this has important implications for accuracy, mission performance, and safety of flight issues. In addition to estimating the orbit state, ODTK also estimates other aspects of the OD problem, including biases in your tracking hardware, environmental parameters like drag, and all of that as a function of time. ODTK also allows you to solve for multiple satellites simultaneously. This can result in much better characterization of commonly used tracking hardware and even more accurate orbit estimates. Another key benefit of ODTK is the ability to process tracking data right through satellite maneuvers with no need to stop and restart your process. And also you're able to calibrate and reconstruct these maneuvers even with no initial knowledge of what happened. Other benefits from ODTK stem from the fact that as a COTS tool, it's been designed from the very beginning to be very flexible and handle a wide variety of OD problems. It natively supports over 65 different measurement types in a wide array of file formats. ODTK has a comprehensive API, and there's a number of places that let you actually add your own algorithms for things like SRP and drag, or add your own measurement file format. ODTK is suitable for a number of different kinds of interplanetary orbits as well, and it's highly interoperable with STK to help extend your analysis for things like maneuver planning, contact scheduling, situational awareness, and conjunction analysis. So if we can, let's bring up the next poll question, the one about the ODTK capabilities.
actually had that out of order, so 1 second. This one?
Yes, that's the one I'm looking for. Yep.
Okay. Okay, so our next poll question, which ODTK capability seems most interesting or beneficial to you? So we'll just keep this up for, I think, about 15 seconds if everyone could give us a quick answer. Unfortunately, Jonathan can't have his screen back until we close down the polls, so we're going to be doing these rapid fire. Okay, a couple more seconds. Getting lots of responses here. Okay, thanks everyone. And
all right, great. Okay, so ODTK is currently used to fly satellites used across multiple orbit regimes and by many different civilian, defense, intelligence, commercial, and other kinds of organizations, for everything from CubeSats to multi-billion-dollar assets. And this list here just gives a quick snapshot of some of our current customers. And of course, this actually is just a list of people who are actually using ODTK in current operations to fly their satellites. As I mentioned, many other customers have used ODTK for other aspects of the mission lifecycle, like design, testing, validation, or other purposes besides live ops. And additionally, AGI has tested ODTK with a lot of real tracking data from numerous other missions and all sorts of orbit regimes. These are all listed here. Note that the asterisk indicate that we've actually processed an entire constellation of satellites, and as of GPS, that might mean we've processed them all simultaneously. In fact, we've actually processed the entire public satellite catalog as part of our testing suite. Finally, ODTK is also at the heart of AGI's Space Situational Awareness software suite, which is a scalable, service-oriented architecture that's recently been selected for use by the U.S. Air Force's Joint Space Operations Center, or JSPOC. And our SSA suite is also currently running AGI's recently launched Commercial Space Operations Center, or ComSPOC. You can follow up with us for more information on either of those. Okay, and actually I think there was another poll question as well we wanted to pop up at this point.
okay, the primary tool question?
Yes, and primary tool one, and then after that also the applications.
Okay, so 2 quick questions here. What is currently your primary tool for orbit determination? So if you could give us a quick vote on that. And also, we had a couple people who joined a little bit late after Jonathan got into his introduction. So I just wanted to reiterate that if you do have questions at any time, you can send them in the questions panel. We'll compile them. Please don't think we're ignoring you, and we will get to all of them at the end. Okay, thanks for your input on that question. Oh, they're still coming in. Okay, I'm going to close that one down. Thanks again. And the applications you're most interested in?
Yes, that's the one.
Okay. And one more. What applications are you most interested in? And as always on any of these questions, we wish that we had a way for you to type in your answers. Our workaround is for you to use the questions panel. So if there's ever any more information you want us to know rather than the constraints of the multiple choice, please just put it in the questions panel. We read everything that you send to us, and any input you have, anything you want us to know about the way you're doing orbit determination, we appreciate. Okay, Jonathan, it looks like we got everybody who answered, so I'm going to close this one down. I'll tell you when we see your screen. Okay, you're up and running. Jonathan, did we lose you?
Oh, here I am. Sorry, I had muted myself.
Okay.
All right, so we're going to go ahead and move into the software now. In today's introductory DIY, I'll show you the basics of how to set up an ODTK scenario to simulate and process tracking data for a LEO satellite tracked with a small network of ground-based tracking stations. Okay, so as you're launching ODTK, one of the first things to note is that ODTK is a very data-driven process. And often this data is coming from real tracking measurements that were actually taken. And so because of that, it's very important to make sure that the underlying data files that ODTK needs are up to date. And you can get to these with the ODTK Data Update utility. And this allows you to download things like Earth orientation parameters and space weather data and GPS satellite catalogs and all these things. So it's a good idea to always update these as you're working with ODTK. Now, of course, if you are running it in some sort of offline environment, a lot of mission control stations are, you still need the data, so you'll have to find some way to bring it in either through some kind of secure proxy server or whatever. So I've already updated this, and we are good to go. So if you're familiar with STK, then ODTK will look somewhat familiar, but it's not exactly the same. We still have the concept of a scenario, which holds all of your objects in your sort of your workspace. So let's create a new scenario now. I'll just call this ODTK DIY. And so the scenario is one kind of object, and all the other objects that we create are going to be showing up here in the object browser. We also have kind of our general workspace over here to the right, and a number of toolbar buttons and different functions like that. Okay, so the first thing we'll need to do is create a satellite object. So I just click over here to add a new object type for a satellite. I'll call this guy Leo. And again, as with STK, all of these objects have different properties that are necessary to define how they work. So you can use the properties button or just double click. One thing you'll notice in ODTK is the properties panels look a little bit different. There's a very organized tree structure, which we may see later on is actually a very helpful thing to have. And so all the different properties that define the satellite, from the orbit state here to the, if we take a look at the bottom of it here, we also have the initial orbit uncertainty of that state. There's lots of different physical properties like the mass, the orientation as a function of time, which is going to be important for some of the force modeling that we see here. So there's obviously gravity, whatever gravitational parameters and settings you want to use, and also drag and solar radiation pressure. And as we look further down, you can also model your impulsive and finite maneuvers as well in all of these properties. So for this simple example, I'm just going to leave all of the default settings here. Now, of course, if you're working with real tracking data, then you're going to need to make sure that these settings are appropriate to your specific satellite. So I'll jump back very briefly to the PowerPoint presentation. Let's see, where are we here? Just to show you that we have a number of different elements to the force models. It's very customizable. You can go into a lot of detail for very high accuracy applications. And again, as with STK, this is actually using the exact same libraries under the hood, our HPOP and Astrogator propagators, so you can have very good interoperability. It's also very extensible as well. Okay, so back into ODTK. So this is where we would configure the full initial state for our satellite. One thing that I would mention is if you are working with a real satellite, chances are you already have some idea of the initial state. So instead of just typing things in manually here, we do have an initial state tool. I'll point out that on the ODTK Launchpad, there are a number of very helpful utilities that have some very necessary functions, and you can look through the list of them there. But I'll jump to the initial state tool just to show you briefly. So if you have some existing ephemeris file or an orbit state or even a two-line element set, you could use these to initialize the initial state here directly. So that's one way to get some starting point of where you think your satellite might be. Okay, so now we have a satellite. The next element to our problem is we need to have some kind of a tracking system. So I'm actually going to import one of the default tracking systems that come with STK. I'll do that with File, Import Object. And so these tracking systems are saved in the ODTK install directory, which is by default in your program files, AGI, ODTK directory. There's a subdirectory here called ODTK and then app data. Finally, databases, tracking systems. It's kind of buried down in there. But you'll see that we have a number of pre-configured tracking networks. Some of these have to do with specific things like the Deep Space Network or NASA's TDRS network. There's also sort of an unofficial version of the Space Surveillance Network, things like that. So we're going to choose the baseline tracking system object. So you see a tracking system consists of individual trackers, or facilities in this case. If we take a look at their properties as well, they're basic things like the position and latitude, longitude, altitude. You can also look at as-el masks of these objects. Then there's much more detailed models too that start to make a real difference when you're modeling the actual measurements taken by one of these guys. So there's things like tropospheric modeling. There's quite a few others as well. Again, we have a PowerPoint slide that shows an overview of what some of these guys are, which you should be able to see here. So some of the other models that are taken into account in the OD problem include, as I mentioned, troposphere, facility motion. There are numerous stochastic models. We can model transponders, multiple antennas, because again, with the OD problem, a lot of times the details matter. So we have the ability to take into account all of that. When we go back into ODTK, another important thing to point out here is here under measurement statistics. So these tracking stations, suppose they're a radar, they're going to be producing data, and it's probably in the form of standard things like, here we have range, Doppler, azimuth, and elevation angles, right? And each of these measurement types have different parameters associated with them that describe things like their nominal biases and how much that bias might move around. There's also the sort of the noise, the expected noise on these measurement types, and then they're all going to be specific. So you could have settings that are specific to a particular measurement type coming from a particular measurement station. Now this is just some of the basic ones here. We have a wide array of different measurement types that ODTK supports. You can see a quick list here. I could add any of these to this particular station. And again, this is just for ground stations. There are, again, quite a number of other measurement types that are suitable for different kinds of tracking problems. So again, we can model ground-based trackers and space-based trackers, and either one, there's a lot of different ways you can mix and match different kinds of tracking data inside of ODTK. So this is a good time for the next poll question. We have a poll question actually about different measurement types.
Sorry, then, I was muted that time. Okay, which measurement types do you want to learn more about processing? And I will reiterate that if you have another type that you'd like to list or give us any more information, please use that questions panel. We had some people who have already used that, and any information is definitely helpful. Even after I close the poll question, if something occurs to you, just write it in there.
So we may try to address some of the specific cases in the Q&A. But suffice to say, in general, the basic steps to setting up an OD problem are what I'm going to show you here. The variations come in terms of how you set up the trackers and how you set up your objects and exactly where the different measurement types sit. So for instance, if you're using an onboard GPS receiver, there would be a few slight changes into how we set things up.
Okay, I'm going to close this one down. Everybody was quick to answer that one.
All right, great.
Okay.
Okay, so now we have a satellite and we have a tracking station. Now we need to get some measurements. If this was a real satellite with real trackers, then we should already have that measurement data. But since we don't, I'm going to use the simulator to create some. So the simulator is another kind of object in ODTK. And again, like STK, there are some objects which represent physical things, like a satellite or a facility, and there are some objects which are a tool to do analysis, such as the simulator in this case. So what exactly is the simulator, and what can you do with it? Again, I'll swap very briefly back over to PowerPoint. So the simulator is used to generate realistic tracking data using the models that you've already created in your ODTK scenario. So it will essentially calculate what is the truth range, let's use range as an example, between my satellite and the tracker as a function of time, but then it can produce random variations in that. It can produce variations to the orbit or to the force model parameters or to the actual measurement itself as a function of the biases and the noise that you tell ODTK to expect for, again, this tracker at this time. You can do variations in maneuvers. You can also limit the simulator to a specific tracking schedule, and then you can actually export the data from our simulator for use in a number of different kinds of legacy systems. So all in all, it's a very useful tool for looking at how you might design your satellite and tracking system to make sure you're meeting your OD requirements, or how to operate it, even in live operation. So you could simulate different potential tracking schedules and see if one schedule is more suitable than another. Okay, so again, in ODTK, we've created a simulator. Here you can see that we're looking at it over a specific point in time, and we're actually going to produce one data point every minute. Down here is where we would set the custom schedule, but we're not actually going to do that right now. We'll just leave a default one, which means it'll essentially track the object from horizon to horizon continuously for each pass. Here's where we'd set up the different error modeling. So in this case, we could change everything about the satellite. In this case, I'm going to not actually change the initial orbit state. I'm going to leave the initial orbit state correct. Okay, so how do we run this? If you select the simulator in the toolbars, there's a little blue Run button. So if I click here, you'll notice the progress bar completed rather quickly. And also in ODTK, the message viewer is a very useful tool which gives you status of how these computations are going. So if I scroll up a bit, you'll see that it calculates my progress through the simulation, tells me I created 452 measurement data points, and I put them in this file. So now the next step is I need to actually tell ODTK to use this file. So how do we do that? All of your measurement files are set at the scenario level. So if I go to Scenario Properties, Measurements, Files, this is where you would add your own data. And you'll notice the simulator very helpfully automatically adds the measurement file that I just created so that I'm ready to go. If I were to click Add here, then I could add another line item. And you'd see a lot of different data types that are present. These are all the default file formats, but you could always add your own as well. Okay, so I don't actually need that extra slot. Okay, so another way that we can look at the contents of this file, there's a quick summary, measurement summary, which is on your toolbar button up here. And this tells me, again, how many data points are in this file. And then also it tells me which objects are present in the file as well. One thing that I briefly skimmed over is every object, every satellite, and every tracker has an ID number that it uses that's associated, so that ODTK can look in the file and say this tracking ID number goes with this object and this other number goes with the other object. If we want to look at some more details of the measurements, there's a view measurements here, and this actually gives you every data point, so range, Doppler, azimuth elevation at every time step for the entire problem. Okay, so now we have tracking data. So how would we actually use this? The next step is we need to create a filter object to actually process through the data. So again, we'll add a new object type of filter. And in this case, it's automatically set up to start with the same time as the satellite, or actually the first measurement. It's going to process through to the last measurement time as well. And so to run the filter, we just select it, and again, click the Run button. As it was processing through here, you see that it actually shows you the status at every pass. So each of these lines indicates a new pass from each of my trackers. And then finally, all the different ephemeris entries and updates for the satellites. All right, so now the next step is how do I see the results of this? How do I know that this is processed successfully or not? How do I evaluate it? And to do that, we use the static product builder. So the static product builder is essentially the reporting and graphing system in ODTK. There's a toolbar button for it right up here if you happen to be following along. And the reporting and graphing works a little different than STK in that each of these processes, when they run, will create something of a small database of information. And then to create the report and graph, you connect the database, if you will, on the input side with the particular output that you want to get from it. So if I wanted to look at one of the first basic things you may care about, which would be, let's say, the residual ratios. Right? So I'm going to take the inputs side, and I'm going to add an input. I need to actually browse for the file, which is here called ODTK DIY. And again, you'll see each of those processes. The filter produced a fill-run file. The simulator produced a sim-run file. So I'm going to choose the filters output and click Open. And now that I have an input connected with an output, the icon changes. I'll give my graph here a name. And so I can select the graph and then run it to take a look at the results. So in this case, this was all simulated data, and everything looks great as would be expected. So you see here all the different data points of the different data types from the different stations over time. So you can clearly see the individual passes over this one day. And since this is residual ratios, I would expect everything to fall within my plus and minus 3 sigma uncertainty. And we can see that everything does look pretty good there. Okay, the next step is going to be, let's look at a little bit more detail here. So another data output that we may care about could be my position uncertainty. And so this is going to, again, use the filter output, sorry, the filter input to my graph, but I'll use a different graph style. So I can copy this existing data product, and I'll rename this filter position uncertainty. So again, the filter run is my input, and the output here is going to be my position uncertainty. So now I can run this. And we see the position uncertainty, again, as a function of time in each of the 3 axes, radial, in track, and cross track. You can see the filter starts to converge a little bit from its initial uncertainty, and as time goes on, it gets a little bit better. This big spike here at the end, you can start to understand things by looking back and forth at, say, your residual ratios. And you'll notice there's a large data gap right near the end of my processing span. Because I have no new data coming in for a while, my uncertainty necessarily grows until I do get a new data point right at the end. So the filter is a great way to process your data going forward only, but to get the most accurate post-processing results, we'd also want to use a smoother. So a smoother is also a separate object type, so I'll use a smoother here. One thing to note is that the smoother requires a separate input file. So if I actually look at my filter object, then one of the outputs, I'll collapse things here and go to output. So there's actually a specific kind of data file that we need to create in order for the smoother to run. We didn't do that before, so I'm going to turn that on and then apply my changes. Now I can rerun the filter very quickly. And now the smoother will have the necessary inputs. I can point to the file here. It's going to be my ODTK DIY filter.ruf file, and accept those changes. And then we'll click Apply. So now, again, we can run the smoother as its own separate computational process. So the smoother completed. And to look at the results of the smoother, it's, again, the same process, but now we need to change the inputs. So this time I'm going to copy my filter position uncertainty. I'll call this my smoother position uncertainty. And now I just need to modify the input. So I can double-click here and then just simply point to the different file. ODTK DIY SMT run for smoother run. Okay, so now I can run the smoother uncertainty position uncertainty graph. And we can see that the results are definitely a lot better if we compare the scales here. So again, the uncertainty has this sort of typical bathtub-like effect where it's higher at the beginning and higher at the end and lowest near the middle. But if you look at the scales here, my position uncertainty in this case is on the order of in track is between 50 and 100 meters, kind of near the middle from the smoother. But if I look at the same time period on the filter output, it's quite a bit higher. You can see more like 200 meters, the red in-track uncertainty. So what we can see here is that the smoother actually dramatically improved my uncertainty result over the same time period. And typically, we will run the filter and the smoother together. Okay, so that's the basic conclusion of a quick run-through of how you might want to run ODTK. There's more details that we can get into in terms of exactly what the filter does and how to configure it for special cases. There's more analysis that you can get into, troubleshooting if things don't go right, or understanding how well the filter and smoother are working together, and really verifying that you have the right kind of OD solution. We're planning to do more DIYs in the future where we can touch on some of these topics and go into a little bit more detail. And just as a quick note, I did want to mention that we have some online resources as well. For those of you that haven't seen it, we have start.agi.com, which allows you to jump into some self-guided STK training, and then also relatively new is ODTK training as well. So this gives you a few step-by-step instructions that walks through a similar but not exactly the same process as we went through today. In addition, we also have a number of resources for follow-up if you are interested in learning more about ODTK and how to use it in different situations. So we have, in addition to the START training, we have customized instructor-led training that is led by an AGI subject matter expert at our location or yours. Not mentioned on this slide here, if you actually download and install ODTK, there are a number of very helpful tutorials that are built right into the help system and address a number of the different special cases. So if you're using TDRS data for your satellite, or satellite laser ranging, or an onboard GPS receiver, it can give you an introduction to how to do that. Okay, that concludes most of the content here. I think we had one last poll question before we move into the Q&A.
Okay, thanks, Jonathan. If you just want to answer what you plan to do next after today's webinar, if you have any idea of that, we'd appreciate hearing about it. Also, I wanted to mention a lot of people did contribute to the questions panel during the polls, so I think I found all of the questions that were peppered throughout, but if I did miss your question, please feel free to copy and paste it again. I literally just missed it with the poll question responses. So, Jonathan, I'm going to read you this first poll question, question that came in, excuse me. I'll close down the poll as soon as you think that maybe you'll need your screen back, okay? So the first question is ODTK a separate software package from STK 10.1?
Yes, ODTK is a separate software package. It's not an STK extension module the way that, say, Astrogator or Pro or Communications is. It is a separate installation. There are a number of reasons that we made that choice, but that is how it works. But as I mentioned before, it is very interoperable with STK. It's very easy to connect the two, and they share all the same data formats.
Also, I should have mentioned, please, you can still send in your questions while we're going through these questions that already came in for Jonathan. What hardware was the entire satellite catalog run on?
That is a good question. I would have to look into that and get back to you. But that was done essentially using our SSA software suite, which, as I mentioned, uses ODTK sort of on the back end of it. It does use multiple core, sort of large memory type of server infrastructures, but it's definitely commodity level. It's not highly specialized hardware.
Okay, I'm going to jump to a poll question that just came in because I think it tacks on to what you're talking about right now. Why would you need both STK and ODTK? What situations require one versus the other?
Yeah, that's an excellent question. So when would you need STK? Well, let me do it this way. When would you need only ODTK? So ODTK is, as I mentioned, a very data-driven process, and its primary and just about its sole function really is to take tracking data and produce an orbit estimate from that. So suppose you are in a satellite mission control center. Often the flight dynamics work that's being done can be broken out by tasks or discipline, and traditionally we've had a lot of customers where they'll have one person or one team whose job it is to create that official orbit estimate as a function of time, and they're always doing that, day after day. And then they will take that orbit estimate and then pass it on to other members of the team to do things like mission data analysis or other kind of flight dynamics things. So they may take that and do conjunction analysis or maneuver planning or any of the other functions that we mentioned. And so often you just have different individuals or different groups even that have very specific roles. And depending on how your organization is structured, if you're having different people in different groups doing those different functions, then one group may only need ODTK, and the other group may only ever use STK. Of course, they do have to exchange data back and forth, but they don't need to use the exact same tools for the tasks that they need. Those lines get to be blurred a little bit if you have a smaller mission control center, or if it's sort of one small team or even one person doing kind of the entire flight dynamics problem. In those cases, people will often use the APIs to automate ODTK and STK and help them to run together. We have a number of examples in our either installed with ODTK or STK or on our website about how you can integrate the two together depending on exactly what you're trying to do.
And we'll make sure that we link to that, Jonathan, when we send an email with resources after this. I'm going to stick with the product rather than the technical questions with one more question, as long as we're on this line. Can you tell us about some of the new features in ODTK?
Sure. So we actually just released ODTK 6.3.2, which is a maintenance release. There were a couple little features added in there. On one case, we added support for a new kind of a new type of tracking measurement that is specific to the deep space network and is used for a lot of deep space missions. Let's see. We also added a capability which allows you to, if you're tracking multiple objects with, say, the same telescope, so it's an optical measurement, and maybe there's a cluster of satellites close together, you can actually add a relative measure between the two objects and then correlate that to the same tracker, and that gives you some of the some additional simultaneous processing benefit that I referred to earlier on. And we also added a number of new graph styles. So that's again just in the latest release, which just came out either today or yesterday. Oh, one more thing I'll mention. In ODTK, if you are interested in what the newest features are, you can always go to the help, ODTK help, and it'll bring up the integrated help system here. And of course, there's a whole section for release notes about what's newest in the newest version or in prior versions, and you can go through all the different major and minor releases.
Can you show how you got to the help? Again, we had the poll question open.
Oh, sure thing. So the help, there's a couple ways. You can just go in ODTK up to help, ODTK help, right there, and then release notes. And it is also on our website. If we look at agi.com/resources, then you can go into the help files, and then somewhere, I think it's maybe near the bottom, and the ODTK help is also on the website.
Okay. In the initial state tool, I see, oops, another question came in. In the initial state tool, I see various file types. What software generates these file types, like .e?
Yeah, so the .e file types, that's actually the AGI formatted ephemeris file. So that would come out of STK or ODTK, so some previous orbit solution or propagation. Let's see, the TLEs come from all sorts of different places. Of course, it's published for the satellite catalog, or a lot of tools can generate sort of their own version of a TLE. You can also use a CCSDS data file, which is an open standard format for both state vectors and also ephemeris files. So the OPM is a single state, and the OEM is an entire ephemeris file.
Can your simulator produce DSN TRK 2-34 files?
Yeah, that's a good question. So the simulator is able to generate measurement types for any of the measurement types that we support. So if you are using DSN data, you can simulate the actual measurement type and how those measurements will behave. However, not every measurement type has a measurement format that can also be simulated, and that has to do with the fact that many measurement formats have specifications which require a valid file to contain lots of external data or metadata that ODTK doesn't necessarily know about. So the point is, even though we can read a file because we're not always using every single flag in it, we may not be able to generate the same file in a way that some external system could use. So it's, I guess the answer is there's a little bit of hit and miss as to whether a specific file can come out of ODTK and go into something else. On the DSN data, I'm actually not sure. I'd have to check on that one. But I know that some of the more open standards, or simpler standards, you might say, we can definitely generate some of those file format types that could then be loaded by other systems.
A question about the drag body model. Can you actually define the shape of the satellite to simulate the perturbances on attitude?
Yes, you can. So on drag, if I jump here in the force model settings down to drag, force model, drag. So the out-of-the-box options for the models are essentially spherical or a plugin. So a plugin is what I mentioned with some of the extensibility that allows you to add your own code. The same thing goes for the SRP models. So we have in the API, we have a very extensive plugin type that allows you to define essentially the shape or whatever drag model that you want to use through your code. So it's not quite a it's not quite a graphical system where you give it a 3D model and then it creates the drag profile directly, but you are able to specify it in whatever method you want, whether that's an analytical model or whether it's sort of a plate model. Now that said, we do have a couple examples of a plate model for SRP and then also for drag that you could use as a very good starting point for defining those things. So if you're interested in that, let us know and we can point you to those examples. In fact, they may actually come installed with ODTK, some of them.
How accurate and reliable are the outputs we get from ODTK?
That's a very tricky question because as with any data-driven tool, there's the question of garbage in, garbage out, right? So if you have very noisy measurements that are very infrequent of an object that you know little about, so say you're taking measurements of a satellite rocket body that might be tumbling or something, then that's inherently a much harder orbit determination problem than something like an owner-operator satellite where you have very good onboard GPS receivers and you may also be doing laser ranging. Right, so it's really a question of how accurate is the data going in. Now that being said, for situations where you do have very good data, like the one I mentioned with laser ranging or an onboard GPS receiver, it's very feasible to get single-digit centimeter accuracy, or orbit uncertainty, I should say, or maybe even better. It really is just a function of the accuracy of your data, the accuracy of your measurements, and also frequency of them, the frequency of those measurements.
Is it possible to use MATLAB functions directly from ODTK?
If you're talking about using the API to input data to ODTK, or to tell ODTK to compute things, or to get some data out, then yes, you can use MATLAB directly. In fact, in our help system, there is a whole section here about integrating with ODTK. And I believe if we looked at the scripting guide, you'll see that there's many different places where we give code snippets of using VBScript or Perl or MATLAB to connect with ODTK. For some of the plug-in models, there are ways to connect your MATLAB scripts into it, but it's slightly more complicated if you want to add MATLAB code as a plug-in. But one example would be force models as a plug-in from MATLAB. But it can be done.
Can you use the output from ODTK to run as a simulation in STK?
Yes, you can, actually. That's a fairly straightforward thing to do. So you can always take the raw output files. So for instance, my filter run here, the outputs from my filter include things like an STK ephemeris file. And you can see as my filter ran, it created this .e file. So I could load that in directly to STK. There's also one of the tools that I didn't use here, but it's built into ODTK. It's called Run STK. And so from the user interface, you can actually tell it to launch STK and then add the facilities and add the satellites that you've created. You can add the sort of the simulated ones and the filtered and smooth satellites and look at those all together in STK. So I'm actually launching STK now, and I'll do this in just a moment as it finishes loading up here. Of course, this can also be done on your own using the API. So if you wanted to build ODTK and STK into part of your own flight dynamic system, let's say, then you could very easily do that using whatever coding environment that you wanted. All right, so here's the STK environment that I just created. So I imported my satellites here, and come over here. Let me make sure I've added my facilities. Here we go. So here are the facilities and the satellites used in my OD problem. And then if I zoom into them, you can actually see the covariance ellipses that came out of ODTK. And then if I animate through here, I can see these change as a function of time. One more thing I'll do, which is helpful as well, I'll tell it to go ahead and compute accesses for each of these objects. Right? And so now as I'm running through my scenario, as I come over one of the tracking stations, which I'll get to Reef in just a second here, then you'll notice that as soon as I start getting access to Reef, my covariance will collapse down quite a bit. I know it's a little bit jumpy over the GoToMeeting, so I'll let it go slowly here. So then the covariance ellipses that you see here, you could then use those for other kinds of analysis in STK, like conjunction analysis, for instance.
Yeah, unfortunately, it's pretty significantly jumpy on our side. So like Jonathan said, that's certainly not a function of STK. It's just the way it's displaying over GoToWebinar.
Okay, any other questions?
Yes, I think we have a couple that we can maybe take offline. But we did have a couple of people who asked about if this is getting recorded. We are recording this. Hopefully we'll post it within a day or two. Then we'll send you an email with a link on how to request an evaluation license, and also a couple more resources that Jonathan had mentioned earlier. A couple of people had some individual questions that came in. We will get back to you on those. And also, if you think of something after the presentation that you didn't get to ask right now, you can send it to webinar@agi.com at any time, and we'll make sure someone gets back to you. Or you can reply to the email that you got from me earlier this week with the link about joining. So Jonathan, I think that's everything we can get to right now. Like I said, look for that email, and unless there's anything else that you wanted to mention, Jonathan, I think that's it.
Okay, great. Well, thanks everybody for attending. I hope you
Okay,
found
thanks
it
for the
useful.
presentation.
Thank you.